Okay, if we know that the number of gallons is going to vary linearly with the time, focus in on this part of the problem. As we set up some ordered pairs here to use, basically the x value for our ordered pair, that should be the time. And the y value, that's going to go with the number of gallons. So with that understood, let's see if we can find some points now from the rest of this problem. We see that after 40 seconds, there are 13 gallons. So one point might be 40 and 13, if we want to keep our time in terms of seconds. Another point, as we look here, it says after 1 minute, you pull the plug and there are 10 gallons left. You've got to be careful here with your units of measurement. If we're letting 40 be the x-coordinate for this point, and 40 is in terms of seconds, when we talk 1 minute for our other point, we're going to have to make that 60 seconds. And then y would be 10 for the 10 gallons that are left. So I established my 2 points. I look at part A here. It says write the particular equation expressing the number of gallons left in the tub in terms of the number of seconds since you pulled the plug. We're going to write an equation. We know to write an equation, we have to start by finding a slope. So let's find the slope based on our 2 given points that we've established. If I take second point to first the way I've written it up here, difference in the y's be 13 minus 10 over difference in the x's be 40 minus 60. My slope is going to be negative 3/20, right? So utilizing that slope, let's come up with an equation now. With our equation, we could use point-slope form to get it started. In fact, you could argue that point-slope form would be enough for an answer here. But since I'm trying to make connections to functions, it would make sense to solve for y. So I'd suggest putting all your answers in slope-intercept form. All right? If we plug in a point-slope form, just selecting one of the points, say I take first point here. It'd be y minus the y value at that point, which is 10, equal to the slope of negative 3/20 times x minus the x value at that point, which is 60. As I said before, solving for y will make sense. So let's solve this for y. If I solve for y, well, let's see. You've got to distribute the negative 3/20 through. So it's negative 3/20 x. I'm going to take negative 3/20 times negative 60. So let's see. That's going to be what? 180 over 20. Negative times negative, so positive 9. I'm adding this 10 over, right? So ultimately, if I wanted to create a function here, have an answer in slope-intercept form, it'd be y equals negative 3/20 x plus 19. That gets us started with an equation. All right, so the idea now for the rest of these questions that were being asked is use this equation somehow to help us answer those questions. If you look at part B, how many gallons would be left after 20 seconds or 50 seconds? So you look at the value that's given here and you relate to the variable that we've chosen for that idea. Is that the x or the y here? It's going to be time, right? So it's going to be the x. X is going to be 20, x is going to be 50. We can plug into our equation over here for x. Now, we could do that by hand, or if you want to use some technology here, go to your calculator. Since we solve for y, and go to y equals, if we go to y equals and we enter in our equation, got to be careful here with the fraction. These parentheses be negative 3 divided by 20, close the parentheses, x plus 19. Should have our table set up where we can enter in some values, right? We know for part B here, x will be 20, x will be 50. So if I go to the table, enter in 20. Oh, mine's not set up. Got to go to table setup. Second window, got to put this on ask. There we go. Now go back to the table. Put in 20. Put in 50. So at 20 seconds, there's going to be 16 gallons left. And at 50 seconds, let's see, what did we find here? There were 11.5 gallons left. So again, just go back to the equation that we found in part A, plug in for x, you do it by hand, you can use the calculator, whichever way you prefer. All right, on part C it says, at what time will there be 7 gallons left in the tub? We see 7 gallons, we know gallons goes with y, so if we utilize our equation and we let y be 7, 7 would equal the negative 3/20 x plus 19. All right, if I'm solving for x here, I might want to multiply through this equation by 20. Right, that would make sense to clear the fraction. If I do that, multiplying through by 20, I would have 140, since that's 7 times 20. Multiplying this fraction by 20 clears the denominator, so negative 3x is left. And then multiply 20 to 19, we get 380. If you subtract 380 over, let's see, 140 minus 380, we're going to have negative 240, right? So solving for x, divide by negative 3, and x will equal 80. That represents a time, so that'd be 80 seconds. All right, on part D, we're asked to find the y-intercept, which is also known as the gallon intercept because the y-coordinate goes with gallons, right? To find the y-intercept, since we solved for slope-intercept form back here in part A, that's not going to be too hard, right? Y-intercept, or the gallon intercept, is going to be 19. So answer to part D here, 19. Stretching our minds a little bit, though, and trying to make a connection here to the real world, it says, what does this number represent in the real world? Any ideas? Mm-hmm. There we go. There's 19 gallons in the tub before we start draining it. Right? Because if you think about it, your time would be 0 at this gallon intercept. So you haven't started draining yet. 19 gallons would be in the tub. On part E, we're asked to find the x-intercept, also known as the time intercept, because x and time are going together here. What does this number represent in the real world? Okay, we'll get to that in a moment here. Let's find the value first. If we're going to find the x-intercept, this is where we have to let y be 0, right? So taking our equation, plugging 0 in for y, 0 would equal negative 3/20 x plus 19. If we solve for x here, again, if you want to clear the fractions out, we can. Multiply everything by 20. You'd have 0 equals negative 3x plus 380. Solving for x, we'd have negative 380 equals negative 3x. Or if you divide both sides by negative 3, x is going to equal, get a decimal back on this, right? The 126.6 repeating. So 126, if you want to round off, we could say 0.7. If you want to give me a mixed number, you could say 126 2/3. The thing is, x is going to be in seconds. So what does this number represent in the real world? Any ideas? Yeah? Okay, so that's the time that it took for the tub to drain. And since that's in seconds, it took the tub to drain a little over 2 minutes, right? Okay, on part F, we're asked to plot the graph of the linear function using a suitable domain. Okay, if you go back now to, well, not only what your equation is, but the given points that we had to work with, the key points that we had to work with, those key points were 40, 13, right, and 60, 10. We're talking about a suitable domain, so we're talking x values that we could work with here to plot this graph. Looks like going up by tens might make some sense, right? So if I mark this off on my x-axis, start at 10, 20, 30, and so on. And then as far as the y values are concerned, those gallon values are concerned, I mean, we got options here. We could go by ones, we could go by twos. The way I set this up originally, I went by twos, just to assure myself of enough space. Okay, so as you plot this out, if you go back to the key points that we had of 40, 13, let's see if I plot that point 40, 13, that'd be up here. And 60, 10, 60, 10 would be approximately right here. I could draw a line through those 2 points. And just to check that I'm on the right track here with previous answers, right, we found some intercepts. You know, we could think about, as this line is extended out, is it crossing the y-axis at the right place, crossing the x-axis at the right place? It's going to be kind of hard to tell here because it is a sketch. But we should be able to have some kind of visual going on here that matches up with our previous answers. The most important thing to appreciate about this graph, though, is notice we are going downward, right? And that should make sense. If water is draining out of the tub, we should notice a downward trend for the line that we're graphing. So when you look at part G now, it says what is the slope and what does this number represent? Well, we know what the slope is. We found that originally as negative 3/20. So we're taking a relationship where we have a difference in the y's over the difference in the x's, right? So the y's were gallons. The x's were time, which was seconds. This is basically the rate at which the tub is draining. That's what that number represents. All right, so key wording in this question says gap width varies linearly with the temperature. Gap width would be the y coordinate, right? And the temperature would be the x. So if we know that's our setup for our ordered pairs, let's take the key values they give us here. Key values they give us, if I break those down to points, the first part it gives us is that it has a gap of 1.3 centimeters when the temperature is 22 degrees Celsius. So temperature is 20. At 20, it's 1.3 centimeters. Other numerical information they provide, gap narrows to 0.9 centimeters when the temperature warms to 30 degrees Celsius. All right, temperature of 30, got a gap width of 0.9. There's our 2 key points to work with. All right, So temperature is 22 on the first point. But we got our 2 points, right? With our 2 points, we can find an equation. We start by finding the slope. If I subtract the second point to the first, I'd be taking difference in the y, 0.9 minus 1.3 over difference in the x's, be 30 minus 22, not 20. All right, if we calculate all that out, well, we get negative 0.4 over 8. Or if you use a little decimal point trick here, this is holding the tenths place, right? This decimal. So if you multiply numerator and denominator by 10, that clears the decimal from the top. Got 80 on the bottom now. If you reduce, slope is going to be negative 1/20. Got your slope, plug into your equation. If we start with point slope form again, doesn't matter which point we play with. What did I choose here? I chose the second point. All right, if I plug in using the second point, it's y minus y value, which is 0.9, equal to slope of negative 1/20 times x minus 30. Solving for y, multiplying that negative 1/20 through, get negative 1/20 x. Got a positive, it'd be 30/20, right? Or 3/2. Now what I'm going to do here, since it's 3/2, I'm going to make that 1.5 since I know I'm adding a 0.9 to that. And we could go either or here. We can keep it as a fraction, switch the 9/10 over if you want, or just go to the decimals. Decimals are fine here though. In fact, it's given to us in decimals, it makes more sense. But y is going to equal negative 1/20 x plus 2.4. Now I have an equation to work with to answer the rest of the questions here. Part B says, how wide would the gap be at 35 degrees Celsius and at negative 10 degrees Celsius? So at 35 degrees Celsius and at negative 10 degrees Celsius, up here gap would be, and down here gap would be. We can do the same thing we did before where we punch this into our calculator. We solve for y right here, so we can utilize that equation in our calculator. So basically I'm taking that out, making that a 1. We're adding on 2.4 here, right? That all look good? That looks good. Go to the table now. In the table I'm entering 35 for x and negative 10 for x. And we get 0.65 and 2.9. Let's see, what's the units of measurement on that? It is centimeters, right? Okay, for part C, interesting engineering type question here. At what temperature would the gap close completely? What mathematical name is given to this temperature? All right, let's worry about the first part here with the question. At what temperature would the gap close completely? How do I need to set up my equation? The gap closes completely. The gap goes with the y stuff, right? Yeah. Okay, so 0 would go in for y, right? That distance would have to be 0. 0 goes in for y. That's going to equal the rest of our equation here, negative 1/20 x plus 2.4. As we solve this one out, let's see, I rearranged this so I had negative 2.4 over here equals negative 1/20 x, at which point, well, you're multiplying both sides by 20, right? And you might as well make it a negative 20 to cancel out the negative sign. x would equal, if I multiply both sides by negative 20, be 48 degrees Celsius. So at that temperature, this gap would close completely, meaning this temperature represents what? What's the mathematical name that's given? If y is 0, we're finding the x-intercept, right? And here, x has to do with temperature. So this would be our temperature intercept. That's the mathematical name we could give to this. So if we're going to find the width intercept here on part D, basically you go back to your original equation, right? Original equation was y equals negative 1/20th x plus 2.4. For the width intercept, which width goes with y, right? X would have to be 0. So if x is 0, y-intercept is going to be 2.4. So our width intercept is going to be 2.4. Be 2.4 centimeters.